Howdy guys. Well, as I guess you remember from the last clip, I got to the stage where the next step was to etch a circuit and move from this onto the photo etch stuff. And then I headed off on my little road trip to meet my boys and hang out with them for a while. So I got back yesterday and my older boy came down with me for a week. So as one does after you've been away for a while, you go and check the mailbox to see what's in the mailbox while you were away. And I guess as many of you guys will have seen evidence of the amazing generosity of people in this community. One of the wonderful things I found in my mailbox when I got back is in here, and here it is, a completely etched circuit board for the project, complete with the solder pins already fitted, and even the two variable resistors, and separately in an envelope, one of each of the transistors that I need to fit on here. Done by one of the guys on one of the UK forums, a really great guy. I won't embarrass him by reading out the letter that he put with it. So what can I tell you? Here we go. The project got turbocharged here, so we can move right into fixing this up. It's just a little bit, he deliberately made the ground planes a little wider, and I just need to trim it off a little bit here so it'll sit down, and then I'll just do a couple of little holes so I can mount it, etc. And once that's done, I can start fitting all the components onto this thing, and we'll be ready in no time. Isn't that amazing? Somebody knew you're heading off for a week and goes to all the trouble of making a circuit board of very high quality. This is made to a very high standard as well. Amazing stuff. Really cool. Right, now I gotta get this thing working, right? No excuses now. Okay, so I've done the physical mounting of the little circuit board. It's pretty tight fit. It's pretty close up to the jack socket, but it's not touching, so we're good. Plenty of room. Okay, so here is the board populated. So next step is put it into the cab and wire it up. A little setback here. I was just starting to wiring this thing up. This is the base of the 4-pole 3-way selector switch. The moment I touch the soldering iron to the first pin to just tin it, the heat appears to have melted the plastic case that this is in, and the result is the pin fell back into the casing, and you can't get it back down. I don't know if I can show this to you guys, but I'll try. So these are all the pins around the edge here, and here is the one sticking up in the air. But it would seem that the way these pins are inserted is they are actually forced in from the bottom here, up to a certain point where they stop and then they bend over the top here. But this plastic is very, very soft, and so this thing melted, and the result is the retaining tag popped through. And well, it doesn't seem to be, even if I got it fixed, I don't think this would be a reliable device to work with. So, and unfortunately I don't have one lying around, so I've ordered up some more sturdy industrial type selector switches, and we'll pick this up when it arrives. Okay, so this is the board wired up, at least as much as I can do today. I gotta wait for that switch to arrive, and then I can wire up the inputs and outputs and all the rest of it. Okay, the replacement wafer switch has arrived, and I've wired it in, hopefully correctly. The only thing I've left open is the positive from the battery, so that I can put the ammeter in and check for power consumption, make sure there's no shorts or anything drastic. The text of the project says when you switch it on you should get around 5 milliamps of current consumption. However, what I've done is I changed one of the resistor values that feeds the power on LED, because I found that putting an LED right across a battery powered device just so you can tell it's on is, well, it's a constant drain on the battery, obviously. And so I experimented and I found that down to 1.5 milliamps this LED here lights up perfectly brightly enough. So I upped the 2K7 to a 4K7 on the board, which reduces the current obviously from about, I think it's rated, it says 2.5 milliamps. So mine is down to 1.5, so I would expect to be a bit less here than the 5 milliamps. So this is where we see did I wire the switch up correctly and what else. So here we go. Okay, we got 3.6 milliamps, and I don't know if you can see it on the camera or not, but the LED comes on perfectly brightly enough to know that it's fired up. Okay, turn you off again. So I'll wire up the battery connector, and I think then we put this aside while I finish up the turret and the rest of the coil. The ferrite loop. So far so good. At least nothing went bang or no smoke emitted at this point. Okay guys, so here is the mock-up of the case for the ferrite loop. So I didn't quite have enough cherry to do the whole thing in cherry, so the sides will be plywood. But since it's all going to be painted anyway, I don't think it makes a huge difference. So as the bottom, I'll put a hole here for the cables to exit. And then I'll drill 2 holes in the center but towards the top on each side for the pivots, which are these guys here. Mine won't be as exotic as this, that's for sure, but I figured I'll put some aluminium tubing as the I'll just epoxy them in each side here and leave them sticking out a certain amount. And then I can make some sort of a bearing for the tube to run in, and that should certainly be sufficient. Okay guys, so this is what the case for the ferrite loop looks like. It's not prize-winning woodwork by any means, but I think when it has a lick of paint, it'll be close enough. So it's all glued except the top, and the top has just got 2 screws, so that if I ever need to make changes, I can get into it and take the ferrite loop out. I made one mistake. This hole here for the mounting lugs is supposed to be in the dead center, but you know, it was a classic case of measure once, cut once, and then regret. So it's like 1 centimeter off instead of 11 point whatever. I did it to 10 point. However, this is probably a centimeter and a half longer than the actual rods. So I'm hoping if I push the whole thing up this end, it'll shift the center of gravity at least a little bit, so it won't be always trying to fall that way. And in any case, it'll be held by the sort of I guess what I'm calling the dial string mechanism. But anyway, okay, so that's it. And here it is with a coat of shellac on it. Actually, it looks not bad at all. I might not paint it. I might just stick with the wood finish. We'll see what the turret looks like. But yeah, so far so good. Okay guys, here's what I've come up with for the turret dry fit setup here. So a plywood base, 2 uprights. The actual project itself shows a fairly elaborate metal mechanism with bearings and stuff up here. I'm going for something more simple, which is stopped holes. And so what I'm going to do is one side will be glued on, fixed permanently, and the other side will just screw on. And so when I've fitted these and cut them to the right length, we'll just fit one end in like this to the fixed part. Then I can just offer this up and screw it down. So that's the plan. That should take care of the fulcrum for this guy. Then I have to do the string mechanism that is here for, it's like a dial cord mechanism for rotating it manually. And then the last bit will be how to have it rotate on the base unit without causing lots of drag. So getting there. So the coil is now fitted into its case, wired in. I've got padding down this end to keep the ferrite rods up this end because of my little central gravity problem. But the tilt mechanism seems to work okay. So I'll put the top on, and yeah, then I just have to do the little plug and socket arrangement at the bottom. So this is the tilt mechanism, which is basically some dial cord and a spring at the other end, wound once around the shaft. This shaft, incidentally, at the moment is just a piece of steel tubing, but it's about the same diameter as your average shaft on a pot, so that I'll have knobs that will go on it. I've left it extra long because in the project text it says you need to keep your hands far away from the loop when you're adjusting, and so I'll mess around with this once I'm using it, and if necessary I can just cut this shaft short and just move the knobs in if it's having no effect. If there is a capacitive effect of my hand, then I'll arrange something sticking out here to make it look a little better. But for now, we have a tilt mechanism which works. It's a little tight, but that's because this is so heavy. In order for this to not slip on the shaft, you need a lot of spring tension. So there's a lot of tension on it, but I think you'll agree it seems to work okay. And so all I got to do now is have the fixing onto the base unit. So, and how it's going to rotate and turn on there. But I have some ideas for that, and we'll get stuck into that now. So my initial solution for the how this turret is going to rub against the base is I've put a number of domed carpet tacks on the base. I've fitted the stereo jack plug. Then I drop this down over the hole. this will tell me how far in it has to be when I glue it into the base, so that the weight is taken by the Carpetax and not in any way by the jack plug. But this, I think this rotates pretty well. Little modification to the base unit. The Carpetax rotating around the top surface here, since this is a rough surface, started to leave a track, so I thought that's going to wear fairly quickly. So I tacked on here a piece of, it's actually a piece of a guitar pickguard, which is quite hard, but it's very, very smooth and shiny. And so I've given it a fair old number of turns with the thing on there, and it doesn't seem to have left any mark at all yet. So I think this would be a more durable solution here. So the jack plug has just been epoxied into the base here. Given the stresses, I think I'm not, even though it's like 5-10 minute epoxy or whatever, I think I'm going to leave it overnight before I go doing anything else to it. Okay guys, so this is the, I'd say at this stage, to this degree anyway, the build is done. So everything seems to, at least the mechanical side of things, seem to be functioning okay. So I put some different knobs on the front here because the other ones were way too heavy. So these are a tad lighter, more practical. Although sod's law, the pot shaft on one was bigger than the other three here. So to drill out the hole in the pot, in the knob, sorry. Right, okay, so now I think we're ready for some testing. So I'll read up on that and get rigged up, and then we'll see, is this thing going to be immediately evident that it works, or are we going to be into some troubleshooting and let's etc etc. Anyway, more to come.